Good afternoon. My name is George Crump. I am the electrical technology instructor at Kansas City, Kansas Community College. And today I'm going to talk about the wiring up of three-way and four-way switches. The reason that you have three-way and four-way switches in some homes is you have areas of the home where, for example, you go out the front door, turn the lights on or off, and you want to turn the lights off at another exit out of your home. You can put a three-way switch at your back door or at your garage door so you can turn the lights on and off from that area. I'm also going to cover, after I talk a little bit about and show you what a three-way switch looks like, I'm going to also show you a four-way switch. And right now I want to show you the three-way switch. This is a three-way switch, and what designates the 3 points of connection is over here on the side. You see there's one point of connection right here, there's a second point here, and then when you turn the switch to the other side, there's a third point. So all of your three-way switches will have 3 connections. And the reason for the 3 connections is the 2 at the bottom, which are these 2 here, are called the travelers. Your hot leg that you're breaking to the light will be connected to the very dark lug here, which is black in color. And then that will allow the current to flow across the travelers to the other three-way, and depending on the circuitry, the lights will either be on or off, and you can turn them on and off simply by flipping the toggle up or down. So there's your three-way. The other three-way is exactly the same, which I have in the other hand, which it has 2 connections here at the bottom for your travelers, one here, and then you also have your hot leg coming into the black colored switch, or the black colored screw up here at the top of the switch. So whenever you have the capability to turn the lights off in 2 different places in your home or on, you must have 2 three-way switches, which would be these 2 items right here. All right, the next item that I want to talk about is going to be the four-way switch, which is incorporated in between the 2 three-ways. And the reason you have the four-way in here is due to the fact that you want to turn the lights on and off at 3 different locations. So the four-way, as you can see, I have it in between the 2 three-ways, and I'm not doing a very good job of holding it, but here it is right here. So you got a 3-way here, a 4-way in the middle between the other 3-way. And so what you would do is, and I want to show you the connections on the 4-way because I don't want you to get confused when you see the 4-way, but I do want you to recognize a 4-way switch when you see one. A 4-way switch has connections 2 on this side and 2 on this side. There's your 4 connections. That's the reason that it's called a 4-way switch. There are travelers on all of these connections that allow the 4-way to switch in between the 2 three-ways, which will allow you to turn the lights on and off at 3 different locations. If I can juggle these a little bit and get them lined up. So you have, again, a 3-way, a 4-way, and another 3-way. And you must notice that the 4-way has to be between the wiring of the 2 three-ways and interconnected with the 3-ways in order for you to control the light from a 3rd location. So the 3-ways, again, allows you to control the lights from 2 locations, and with the 4-way in between the 2 three-ways, you can control the lights from 3 locations. So that's my part of the information as it relates to the circuitry. I'm now going to demonstrate to you what it looks like when the lights are operational on a display that I've put together. Okay, now I'm going to demonstrate the actual wiring of the 3-way. And what you have here is 2 three-ways with a light. And I'm going to show you the 2 locations you can turn the lights on and off for. For example, I can turn the light on here. Then I can go down the hall and turn the light off here. Or if I'm up the stairs or down the stairs, I can turn the lights on when I come down the stairs. And then when I go back up the stairs, I can turn the lights back off. So again, you're seeing 2 different locations that the lights can be controlled from when you have 2 three-ways in the circuit for the lighting. Okay, now we have an example of what 2 3-way and a 4-way switch that allows you, the customer, to turn your lights on and off at 3 locations in your home or residence. I can be at the top of the steps in my home and on the 2nd floor and turn the lights on at this location. I can walk down to the bottom of the steps and turn my lights off at the bottom of the steps. And then on my way out the garage, I can have another switch by my garage door and turn the lights back on at that location. So that allows me to turn the lights on and off at 3 different locations. And they can be 3 different locations throughout the home, just depending on how much wire you're going to use to wire up the 2 3-ways along with the 4-way in between the 2 3-ways. Okay, on the 3-way and 4-way switches, one of the tips that I want you to be aware of, when you wire up this circuit, sometimes at one location the light will come on, and at the other location where you're trying to turn the light off, it will not go off. When you have that type of a situation, it's usually an indication that you have crisscrossed your travelers. There are 2 wires that travel between the 2 3-ways and the 4-ways. If you get those wires crisscrossed in terms of the location on the switch, it will allow the circuit to only be operated from 1 location instead of the 2 locations or possibly 3. So be aware of that if you've got it wired up and it only comes on and off at 1 location and you can't turn it off at the other. You need to check your travelers to make sure that your travelers are wired up in the same manner in which you wired them up at the first location.
In this video, we're going to wire in a combination circuit. In this combination circuit, we will be able to see loads in series and also in parallel and see how the system will be affected by having a combination circuit. We have the power source here, and we're going to put 2 bulbs in series and 2 bulbs in parallel with each other. And we're going to see how this circuit will react with each other. We're going to start with the neutral side. We'll start changing from the hot side, and we're going to jump through, come out of first bulb, go into the second bulb. Now we have a series circuit. Now I would still like to put it in parallel the next 2 bulbs. So we're going to come out of the power source. The first bulb will be in parallel. We're going to go to the next bulb and put it the same power source from the hot, from the power source to the first bulb to the second bulb, so receive the same voltage. Now we're going to go to the neutral side, go into the first bulb, come out of the first bulb, and go to the second bulb. Now, these 2 bulbs are in parallel with each other. These 2 bulbs are in series. So when I turn the power source on, we're going to look to see how it will affect each other. Now, if you look at it, these 2 bulbs are glowing very brightly. These 2 bulbs are dim, but if I take off the power source from one of these bulbs, these 2 will go dead, because in a series circuit, if you open up any of the loads, you will kill the whole complete circuit. Put it back, you see it will glow. Different with a parallel circuit, each branch line is individual from each other. So if I take the power off of it, only the bulb that I disconnected will go out, and the other one that's in parallel will continue to glow. So this is a series parallel circuit, or what we call a combination circuit. And so this is the most common type of circuit you would find. In HVAC, what you normally would find is combination circuits where the loads will be in parallel and the switches will be in series of the load. So in that case, you'll be able to have a combination circuit.